Welcome to Vision to Venture. I'm Eddie, and I'm here to uncover the realities of scaling and building a tech startup. Each week, I speak to leaders within the tech space with their insights and advice on how to found, fund, and frame a tech startup. So make sure to follow and subscribe to never miss an episode. Hi, and welcome to another episode of Vision to Venture. Today, I am joined by Maksym Kalaidov, Head of Application Engineering at Neuroconcept. Join us as we discuss Maksym's journey from mechanical engineering to machine learning. Hello, Maksym. How are you? And thank you for joining.
Hi, Eddie. No, thank you for having me. I'm great. Thank you very much.
Glad to hear it. So just to kick things off, do you want to just start by telling us a little bit about your role as Head of Application Engineering at Neuroconcept and what this involves?
Yeah, happy to. Maybe if you don't mind, I'll just start by telling a bit about the company, like what we do, and then it will give you a bit
Absolutely.
perspective
100%.
on what my role is in all of this. So at Neuroconcept, basically, we sell the software that helps engineering companies build products better and faster. And by products, I mean mostly like physical products, something that has a 3D shape, because what we specialize in is machine learning for 3D objects. Now, how does it work is basically there are a few steps to it. The first one is we can learn from historical data of an engineering project. You can speak of, for example, an external aerodynamics project, like any car vendor in Germany. We can learn from the designs of the past, and then we can, for example, learn the behavior of airflow around the car. Mm-hmm. And then what we can do is predict this airflow for next generations of those cars.
Okay.
The cool part about it is that inside of our platform, we also have generative capabilities for 3D geometries. And if you combine this with predictions, you can obviously optimize it and you can do it real fast. Not only fast, but because you are able to evaluate much more designs cheaply, you can get much better designs too. So you have two benefits with no cost or little cost.
Nice. I always like that.
Yeah. And now all of this is obviously like it's quite exciting and cool, but it's quite a new technology, and it's not so easy for companies with processes that have been in place for decades or even more to change and to adjust to the new ways. So to help them do that, we have a team of application engineers who basically help them on board. Our application engineers train them on the technology, explain how it works, what are the limitations, also help identify the actual use cases, and then basically build the automated workflows for the customers to use and actually extract value from it. Now, my role in all of this is actually fairly simple. I just make sure that all of my application engineers have everything they need to do their job. That they are happy with the state of the product, because sometimes there's a lot of feedback that we need to convey to the product team. I make sure that the knowledge is being shared amongst application engineers, and for example, from research, I have to make sure that everything that's being developed is actually being used. So yeah, this is my role.
Amazing. So it sounds like you've got a very busy time organizing all of these different people to do their jobs then, and sounds like a lot of people actually report into you then.
Actually, yeah, my team is actually not that big. We're currently 4, but we are expanding.
Nice. It's always good to hear that.
We've been growing fast. I mean, the company is growing fast in its own. We are, I don't know, like we were 15 like 2 years ago. Now we are over 50. And back when I joined less than 3 years ago, I was the first employee in Germany. Now in Germany we have 6 people. Sorry, 6 people.
Okay.
So yeah.
And so obviously you've come from like a mechanical engineering background. Could you share a little bit more of your journey from being a mechanical engineer to delving into the world of machine learning and sort of what it's inspired or motivated that transition?
Sure. I would say that even as a mechanical engineering student, we are very often exposed to huge amount of data.
Mm-hmm.
Like if you do an internship at any mechanical engineering company, you can clearly see that they have so many designs, so many ideas over the years. They run a huge amount of simulations or physical testings, and all of this is data, right? All of this is someone is extracting some knowledge out of it. Like engineers creating a few designs, submit some simulations, and then they look at it and they make some decisions. So they look at the results and they're like, okay, so this was a bad idea, this is a good idea. And what happens with this is very often the data is just being deleted afterwards. This is like a very classical approach. Just you extract the value and you throw it away. And like even for a student, if you just heard of machine learning, you start getting ideas that okay, there should be a better way to utilize this data, especially since generating it costs like huge amount of money. It's not like I'm not talking about hundreds of euros. It's like millions. It's literally millions for companies. So yeah, but then I must add that while all of this sounded exciting to me when I was a student, it's a technical opportunity for a student, who is just young and eager to do some cool stuff. You don't think much about do people need it actually? Like, is anybody going to be using it? Is it a viable product? Viable idea? And I was just lucky, I would say, that it was a good idea to combine this mechanical engineering data and machine learning. And I can clearly see now that I'm in the industry that there's a lot of not only potential technically, but a lot of need. Like companies actually struggle with retention of this knowledge that they extract from these designs and simulations. Someone like a senior engineer has learned from it, and now they are very experienced and know a lot. But what do you do when young engineers come on board? When new generation starts designing? Like you have to explain to them everything from scratch, right? You have to write huge textbooks where you try to put some undescribable knowledge into words, and but this is just experience. And indeed, you can learn from this data. You can put experience into some like models that then younger generation can actually build on top, not just try to replicate. You can do better now. Yeah, so this is how I came to it.
And how would you say your background in mechanical engineering actually influenced your approach to understanding and applying machine learning concepts?
I would say, so I'm not sure if it comes from my mechanical engineering background or if it's just my personal thing. But I really like to visualize things, like visualize ideas in at least in my head. It doesn't have to be a physical like on paper. But if I really need to understand something, I have to be able to visualize it. And this is something that's fairly easy to do in mechanical engineering. This is also how you're being taught. Like if someone like tells you how to design a gearbox, they show you gearbox. You have the ability to play around with it and see how it turns. And I think I always try, and I'm still trying to to apply these techniques to machine learning. Whatever the concept I'm trying to learn, I really am trying to visualize it in my head, and I think that helps me a lot. If I cannot visualize it, the high chances are I'm either not going to understand it or going to forget it real quick.
Yeah. And so obviously going from having that mechanical engineering background into this a bit more of like everything, having machine learning obviously under your belt as well. Would you say that there were any sort of major challenges that you faced when transitioning from traditional engineering to machine learning? How, like, and if there were, how would you say that you sort of overcome them?
Yeah, I would say that there are indeed a few, and one of them is basically kind of related to what I was just explaining about, the way I understand some concepts.
Yeah.
In mechanical engineering, it's not always the case, but for most situations, there is like a causality chain for things. Like if someone tells you this is how you should design a gearbox, or I don't know, whatever you're designing, you can always ask, yeah, but why? And they're going to tell you, yeah, because like the torque is going to be translated like this. Yeah, but why? And there's also always going to be an answer. In machine learning, it's quite different. Very often you can ask, yeah, but why? And people can tell you, because I tried it and it worked. Why do you, what else can I tell you? I don't know. It just worked. It's like a lot of knowledge is empirical, right? And there is also a lot of empirical knowledge in mechanical engineering, but I feel like sometimes if you don't deal, you can learn about some concepts and you try to remember some facts that you should be doing this and that in those situations. But if there is no clear causality chain and you're not actively practicing those things, it's very easy to forget. So this is for sure one one challenge that one needs to overcome. But I'm not sure if it's specific for mechanical engineers or just in general. But then another thing, at least for me, it's math. Like if I'm trying to read a complex paper on some novel 3D deep learning technology or like framework, very often the mathematics of it gets quite tricky. Like mechanical engineers do have mathematics in the curriculum, but it's quite different. And to me, it leads to the fact that whenever I try to understand some complex concept, I really need to talk to someone who deeply understands it and can explain it to me like I'm five, And this is how I learn things. I ask people to explain to me, like I assume that I don't know anything.
I
And
feel
just
like
explain to me like
but that's the easiest way to learn things sometimes, if it's like just brought down to a lower level and then just sort of build from there. I'd be the same. So there's like nothing wrong with that. It's a way of learning, and if it helps you and you actually learn from it, then great. It's clearly working. So it makes sense. And obviously if that's your way to sort of overcome those sorts of challenges and it works, then great, because I would probably, if I was in your position, I'd do the exact same thing. And to be honest, I have done when I started working in this job. And I mean, I had no idea about machine learning. I didn't know anything about it. And
yeah,
it wasn't until I actually started talking to experts in the industry and
yeah,
running this podcast that it helped me understand it a little bit more, because I'm not technical in any way, shape, or form. I've
sure,
never, like, I didn't go to uni. I've never done sort of degree in computer science. But even just talking about it and hearing about it from professionals where they know that I'm not an expert and I've like never done that sort of thing before, it does help
yeah.
because it's sort of explained in a way that I know that I'm going to understand. So yeah, I completely agree with that. And what would you say sort of benefits of transitioning from mechanical engineering to machine learning are?
Well, my opinion is that basically machine learning is not, or I would put it differently. I don't think that there is a one fit all solution, right?
Yeah.
This includes machine learning. To me, machine learning is just like it's just a tool in your toolbox, And we as engineers, and I'm not speaking specifically about mechanical engineers. It could be any kind of engineers. We always work on the hardest problems. The problems we are facing are more often than not extremely challenging.
Mm-hmm.
And for the right problem, you always need the right tool, right? You cannot saw a piece of wood in half by using a hammer or something like this. You
Yeah.
need the right tool. And
Yeah.
to me, what makes me like just super happy when I think about it is that now I have this skill, and this is just like another tool in my pocket, and I'm just empowered to solve more problems than I was before, and I think this is the biggest benefit.
Yeah, yeah, that's fair enough. And between the two of them, if you had to pick which you'd preferred over mechanical engineering and machine learning, would you be able to pick?
I don't think I would. It's been a tough fight in my life ever since I was like a little boy. I think I was fascinated by both like physics and computer sciences. Even when I was like in my first grades and I got my hands on the computer, I really loved coding. I still do it like on daily basis, and I really love both. And I think my position right now, I'm working on physics problems or mechanical engineering problems using machine learning. It's like a dream job for me 5 years ago. So I consider myself pretty lucky.
Yeah, yeah. It's good that you like enjoy both as well, and at least you can still do both as well in your sort of current role and like keep that
Yeah.
sort of fire burning. And so as the head of application engineering at Neuroconcept, what would you say are some of the sort of key responsibilities and initiatives that you're sort of currently leading?
Right. So as I already probably explained, a huge part of my role is to make sure that knowledge is being shared, that all application engineers are aware of the best practices we just developed maybe like yesterday, and all the latest developments from the research. So basically, this is something that I work closely with my counterpart in Switzerland. So we have an office in Germany, we have an office in Switzerland, and there is a head of application engineering in Switzerland, just like I am in Germany, and this is something that we work together very closely. My main goal is to make sure that engineers can work on engineering problems, and then the rest will take care of it. Like all of these topics about documentation and knowledge share, we try to build the processes around it and make sure that they are easy to follow. And yeah, right now we are working on some processes to basically ensure that application engineers can work easily on not only on their projects, but also on some topics that are interesting for the whole team. For example, some best practices for a particular application. We try to make sure that there is one responsible for this application, and that they now know in the lead of this topic, and they can share the knowledge, and they're responsible for it to be documented. And it takes a lot of load of the rest of the team, because now not everyone is responsible for everything. It's like we
Of course.
try to
Yeah.
divide this. Also, one big topic for us is collaboration, because we as application engineers, we work on different projects with different customers. It's very easy that you either work isolated or just with like 2 or 3 people that you see very often, and you work with them very closely, but you don't communicate with the rest of the team. You don't communicate with some research or product people, which you could really benefit from. And one thing to make sure that there is more collaboration inside of the team and between like cross teams is we organized a hackathon where people were like, we took 2 full days to work on some problems that were mostly not very, like some topics that are not super clear for everyone. Like we made a survey to identify some problems with this understanding of our technology inside the team, and then the application engineers and product and research people work together on those, and I think it was a big success. Like people, like the things that we created, maybe not all of them were super useful, or like you couldn't just give them to customers or put them into the core of the software. But the collaboration is just great. Like the feeling that you learn new ways to work and see how other people think. It's wonderful.
Yeah, yeah. Yeah, no, that's really great to hear. And it seems like you're doing some really great stuff as well, obviously over at Neuro Concept. And just to sort of wrap things up, I just wanted to ask, do you think you could share any advice for any sort of aspiring engineers or data scientists who are interested in exploring the intersection of engineering and machine learning?
Sure, I do. I have a couple. One important thing is that when I remember myself when I was a student, and I saw these people learning about AI, machine learning, and they all seem to be so advanced, so much in front of me, and have so much knowledge already, and they were working their projects. I remember thinking, like, how can I ever be better than them? How can I ever achieve what they have and compete on them on the job market? And the thing is that I really don't think you should think like that. You shouldn't try to compete with them.
No.
The only thing, or like the only person you should compete with is yourself yesterday, and
yeah,
and you should just become better and better every day. Now some people listening might say, yeah, but on the job market, it's not the way it works, right? You're competing literally against other people. My experience is that most of the people don't do it. Like they don't become better than they were yesterday every day. And this is where you can achieve great things. Like if you work on it, and by it I mean anything, but in our case, machine learning. If you work on machine learning for 10 hours a week for 2 years straight, there is like the chances that you're not going to be recognized as an expert are virtually zero. So yeah, this is the way to do it. And the second point, it's hardly related. What I learned is in topics like machine learning and maybe software engineering, practice is extremely important. Like
of course.
it's not you cannot get into the field by just learning about concepts and theories. You have to build things, and there's lots of ways to build things. Like if you are a university student, and every university has lots of topics to explore now on the boundary between machine learning and mechanical engineering. But if you're not, you can find an open source problem to work on. But this is crucial to do it, and not only do it, but also show to the world. Like you need to have a GitHub profile or a personal blog or something where people can check it out and be like, okay, so this person knows what they're talking about.
So basically, ignore what other people are doing, focus on your bettering yourself, and just consistently practice.
Exactly. You got it right, Andy. This is the way.
I mean, yeah, and it is. You're so right, and it's like that with everything, isn't it? Because it's like if you're focusing on other people's success and not your own, you're not going to get anywhere because your focuses are in the wrong place. You need to always just be focusing on bettering yourself, and whether that's small amounts or masses of amounts, it's improvement either way. So any improvement is good improvement, and as long as you practice, you're going to get there. And
100%.
I would stand by that. I completely agree with you, and I think a lot of people will. So thank you for that last bit of advice. And also thank you for joining me on Vision to Venture. Appreciate you taking your time out your day for this. It's been very interesting hearing about your story, Maksym. And I wish you the absolute best of luck in your future. And also the best of luck for everything happening at Neuro Concept. So yeah, thank you
Thank you
very much.
very much, Eddie. Thank you very much for having me, and it was really great to talk to you.
Absolutely, appreciate it. Take care. Thank you for tuning in to this week's episode of Vision to Venture. If you're listening, make sure to give us a 5-star review. And if you're watching, like and subscribe to listen to more inspiring stories from leaders in the tech space.